Hi guys, we've been talking about trend lines and R squared. So in another piece of homework, you saw a video about the relationship between significant figures and uh, the relationship between significant figures and the cost of different balances. So that was this video. If you haven't watched it, I suggest watching it. But right now, we're just going to talk about what R squared means. So what I have is number of sig figs for the different balances and how much they cost. And when I look at this graph, I notice it kind of looks like a Nike swoosh. However, in class, when we talked about lines of best fit, we only talked about lines of best fit. So I fit this line to this data. And if you look at the R squared, it's 0.673. And that makes sense because this data point's kind of close to the line. This data point's not too far away. This data point's pretty far away. And this one's definitely far away. So about half of them are close, which is kind of what the 0.673 is telling you. Right? This data is somewhat correlated to this line. Right? The data is somewhat tight. There's a tight relationship between the data and the line. Somewhat. That's what 0.63 is telling you. 0.673 is telling you it's somewhat correlated. It turns out that I see this Nike swoosh, and if I want to see if this equation is not linear, it doesn't really look linear, it looks like it's curving, I can change my type of trend line. So we talked about how to go to about how to edit your chart. So I went to the chart editor and I went to customize. And then from customize to look at trend lines, I go to series. I'm going to scroll down until I find trend line. And obviously I've already turned on the trend line because you can see it here. Obviously I've already showed to have the label be the equation. Right? And I've already checked on show R squared. If I want to switch my type of trend line, I can change that by going from linear. I think this looks exponential. It looks like it's got that swoosh peak shape I would see for exponential. So I changed it to exponential. Here is the equation for the line of best fit if it's exponential, right? 0.55e to 1.19 to the x, right? 0.55e raised to, that's what this caret means, 1.19 times x. And if you look at the R squared, it got much, much better. The R squared is now 0.988. And that's because this dot is close to the line. This dot is close to the line. This dot is pretty much on the line. This dot is much closer to the line than it was before. And this dot is much closer to the line than it was before. Because the dots are closer to the line, we say the data is much more strongly correlated. And that's what R squared shows us too. R squared shows us of 0.988 shows us that the dots are correlated strongly to the line. Okay, so the academic language for dots are close to line is strongly correlated. Right? And the academic language is dots are not that close to the line is somewhat correlated. Right? And if this was even lower, right, if it was below 0.5, we would say it's not correlated. Right? We would say it's not correlated at all. So in the previous video, I made the argument that sig figs and balance cost are correlated. Right? Sig figs show you how much the measurement costs, and it just happens to be that the cost of balances are actually exponential. Right? It's much, much more expensive to get 8 sig figs than it was to get 7 sig figs. That's what this is telling us. It's an exponential increase. So